Hi, welcome back to the Optimal Heat Source Scheduler. In this tutorial, I will explain to you the parameters of the tool. But firstly, I will show you what the tool assumes for the heating system. Mathematical background of the tool can be found under the Publications part of the Store4HUC website. It is described in the document called Finalized Software Tools as Module 2. The center point of the heating system is thermal energy storage. This thermal energy storage is assumed to be a cylindrical storage tank filled with water. It receives heating power from the heat source and provides heating power to consumers, that is, the demand side. It also loses energy due to temperature difference between the water in the tank and the surrounding air. Inside the storage tank, there is a temperature difference between the top and the bottom, and it is assumed that this difference is constant during 24-hour period. Now to the parameters that are separated into 5 different sections: demand side parameters, heat source parameters, storage tank parameters, and simulation parameters. So let's start with the demand side. Basically, there is only one parameter for the demand side, and it is the required supply temperature. This will be the minimal temperature in the top part of the storage tank, since the water used for heating of the demand side is taken from the top of the storage tank. The power demand profile is also part of the demand side, but it is explained in the first video tutorial. Now, the heat source parameters. The tool assumes that the output power of the heat source can be regulated between its minimal and maximal values, and that its efficiency depends on that power. Therefore, maximal power represents the maximal power output of that heat source, and minimal power represents the minimal power output of the heat source when it is turned on. Efficiency at maximal power is the efficiency of the heat source while outputting the maximal heating power. Efficiency at minimal power is defined analogously. These parameters can usually be found in the datasheet of the heat source. Warm-up time is the amount of time required for the heat source to heat to operating temperature from being cold, as the tool takes into account the dynamics of the heat source. Volume and height are physical dimensions of the storage tank. Insulation type represents the material used for the insulation of the tank, which adjusts the thermal conduction coefficient accordingly. If there is no required material in the drop-down menu, you could choose a material with the same thermal conduction coefficient, or at least a similar one. Another parameter related to the insulation is its thickness. Maximal allowed temperature in the storage tank is defined by the manufacturer of the tank, and it is usually a few degrees below the boiling point of water. Typical temperature difference between top and bottom is the temperature difference between the water in the top and in the bottom of the storage tank. The required value is said to be typical as the tool assumes a constant temperature difference. Surrounding air temperature is the temperature of the air surrounding the tank. For example, if the tank is placed in a basement, this parameter equals to the mean value of air temperature of that basement. Last part are the simulation parameters. Number of power changing intervals is the number of power changes of the heat source during the 24-hour period. For example, if the number of power changing intervals is 12, the tool will schedule power changes every 2 hours. With higher number, the tool can yield greater energy savings, but some heat sources cannot handle frequent power changes. Also, these power changes include turning the heat source on or off. Start time and date don't affect the calculation process. They simply change the time step values that are displayed on the charts. Those will be all parameters. For more information, please refer to the user manual or other video tutorials.